So Ms. Avantika, this is what we discussed last time. Introduction to calculus. I'll just spend 2 minutes discussing what we had discussed and then we'll start. So we started with a broad classification of calculus in two parts, differentiation and integration. Then what we discussed was what are dependent independent variables. We understood that y is a dependent variable. In terms of maths, in the language of maths, it is written as that y is a function of x. So whenever you see this, y is a function of x. You know, in basic common language, what it says is that y takes the value whatever is guided by this function, So as per the guidance of this function, y takes the value at these values of x. I'll explain myself again. So for example, I say y is equal to x square. I say y is equal to root x. I say y is equal to log x. I say y is equal to sin x. Now, because you will be seeing this terminology being used often in our lectures, so y is a function of x. So what does function imply? Function implies that what are you doing on x? What are you doing on x to generate y? Let me repeat. So for example, in this case, in the first case, what am I doing on x? I am squaring x. So in this machine, what am I doing? This function, the name of this machine is a function. So in first case, whatever x you put, this machine will square it and will vomit a value of y. In second case, the machine has a duty of finding the square root of any x that you put inside. So for example, if I put 4 inside this machine will take a root of this 4 and will vomit out 2. In this case, what this machine will do is this machine will take any x which to it. This machine will take a log of it and will vomit out 1. One thing, is it making sense?
Yeah.
So in this case, this machine. So this function, in short, what I'm trying to tell you is that whenever you see, again, last time also what we had discussed was because, see, as a medical student, you won't be interested much about what is a function and types of functions and falana and kana. You won't be interested much in that. But all I want to tell you is that what is this function? This function can be, can be looked at as a machine where x is put, and depending upon what is the mode. So for example, you have this, you go to barista or you go to Starbucks. So if you have seen, they would have this machine here. Yeah, let us take a simple example. You go to McD's. So when you go to McD's, they always have this cold drink machine where they have 3 or 4 types of drinks which are available. Is it making sense?
Yeah.
So what I'm trying to tell you is that this function is basically a machine. What this will do is you put this, basically you just put water in this machine, and depending upon the button that you press, so for example, you press this root x button. So what this root x button will do is it will take this x, and whatever x you put here, it will generate a value of y. Now this output can be square. So by square, what I mean is whatever x you put, it will just take a square and will generate another y. Is it making sense? Am I making sense to you? So basically a function is a machine in which once you put an input in terms of x, it will generate an output in terms of y. One thing, is it making sense?
Yeah.
So if I define this function as a square root. So this is how this is another way in which this will look like. This will look like y is equal to root x. Now whatever x I put here, this machine will always take a square of it. So if I put x is equal to 100, what this machine will do is it will crunch the numbers by taking the square root and will vomit out a 10. Is it making sense?
Yeah.
But if this machine had was in the mode of log x, then if you had put 100, it will vomit out a 2. Is it making sense?
Yeah.
If this machine was on that mode of y is equal to x square, then it will vomit out. Are we clear about this? Avantika, are we clear about this?
Yes, sir.
So why I am discussing this? Because you will find this notion being written. So for example, they will write something like fx is equal to x square. Do you see this?
Yeah.
So for example, in last lecture, what we had discussed was dy by dx. What does dy by dx means? In last lecture, what we had discussed is basically dy by dx is where this limit delta x approaches 0 and I write delta y upon delta x. Do you remember?
Yeah.
Now, this y, last time we took the example of y being equal to x square. But another way this might be written as that fx is equal to x square. So basically, this fx is my y. So whenever you see this fx, it is basically my y. Is it making sense?
Yeah.
So for example, last time I was writing this as xy, but I can very well write this as x fx. Is it making sense?
Yeah.
So f is that machine, is that mode in which the machine is working. So for example, that mode can be a square, it can be square root, it can be log x, it can be cube. That whatever you fed into the machine, it will make a cube out of it. Whatever you feed in the machine. So for example, maybe it is on raised to power 5 mode. So whatever number you feed in, it will take fifth power of that. Is it making sense?
Yeah.
Because this terminology becomes confusing. So if y is written as fx, this dy by dx is written as f dash x. Is it making sense?
Yeah.
Because this terminology you will often see in physics books, in maths book, and we shouldn't get confused whenever we see this terminology. Is it making sense? So that is what they are trying to tell you here, that there are different ways of writing differentiation. So if this is a function, this function can very well be written as fx is equal to x square. Then if you write dy by dx, it can very well be written as d by dx of fx, and this whole can be very well written as f dash x. Is it making sense? Am I making sense?
Yeah.
I can very well put this value of y. So this can also be written as d by dx of x square. Is it making sense?
Yeah.
Because you guys are new to the world of calculus, so we should be trying to make the journey as smooth as possible. So what this says is that, and what I always suggest to my students is that they should be very familiar with the common graphs which are used in calculus, at least the common graphs. So this is a function y is equal to x cube. So this is a graph of y is equal to x cube. Now if I want to take dy by dx, I can write dy by dx, or I can write f dash x. I can very well write it as d by dx of x cube. Is it making sense? Is the terminology making sense?
Yeah.
And one thing that we had discussed in last time in detail, what we had discussed was that, so here we were differentiation, integration, broad understanding, then dependent, independent variable. Then we discussed the importance of graphs. Again, I am specifying the importance of graphs. And then what we discussed was, we actually one thing that we did was that we, using the first principles, what we did was we took this example that if I want to find the differential of x square. So this route that we had followed, that y is equal to x square. Now I want to prove using first principles that the differential of y is equal to x square is 2x. This is all this tamjam that I have done. You don't need to do all this tamjam for a simple reason that now I am giving you this formula that whenever you see a function y is equal to x raised to power 5, you don't have to use the first principle. First principle implies that you start from absolute basics, as basic as is possible. So when we were doing this derivation, we were using the first principles. But what I'll be discussing in this lecture now would be that I will be just giving you a formula. So whenever you see a function like this, y is equal to x raised to power 5, and I ask you what is dy by dx, I am giving you this formula that dy by dx is given by n x raised to power n minus 1. What is n in this case? The n is 5. This is my n. Avantika, is it making sense?
Yeah.
So the answer of dy by dx of x raised to power 5 would be given by 5x 5 minus 4 and 5x raised to power 4. Avantika, is it making sense?
Yeah.
I can write this as f dash x also. Is it making sense? Avantika,
Yeah.
is it making sense? Yeah.
Yeah.
Now, this is the formula part, but I always want you to understand that what is the implication of this, and this is what we were trying to understand last time, that differential, what does basically a differential do? A differential, end of the day, all it does is it lets us find the slope of the curve at any point that I want. Now what do I mean by this? What I mean by this is, for example, we take this same example that we have taken now, that Okay, let me take another example now. So for example, I want to find the differential of y is equal to x cube. Y is equal to x cube. So dy by dx, Avantika, try to tell me what is dy by dx of x cube. What is the formula? You can check your notes here. That is not an issue.
Oh, okay. Then just a second.
Yeah, you can check your notes. Can you tell me the formula when y is equal to x raised to r n? What is dy by dx? मिस्टर रुद्र आप बताएंगे
3x
अरे भाई फॉर्मूला क्या है x रेस टू r n का
and x
रेस टू पावर
n
N
minus
x
1.
n minus 1.
so Avantika what should be dy by dx if y is x cube try to give the answer what is n in this case
3.
so what should I write first I will write 3 then I'll write x and this will be 3 minus 1 is it making sense Avantika so this is 3x square. So dy by dx is 3x square. Is it making sense?
Yeah.
Okay. Now let us discuss. Let us take this very simple example. Of course, we'll be looking at the formulas also, but let us try to understand the implication. That what does this imply? We had discussed this last time also, but let us just reiterate what we were discussing last time. So maybe this is a function of displacement is to time. So if this is a displacement is to time, then I will write this the same function as x t cube. Avantika, is it making sense? What I've said? So dx by dt would be equal to 3t square. Is it making sense, Avantika?
Yeah.
So what is this dx by dt? So you can note this down again. We had discussed this last time. You can note this down again that velocity is given by dx by dt, the first differential of displacement. Acceleration is given by dv by dt. Can you note this down? So if I take differential of x, so this 3t square, this dx by dt is actually my velocity. Is it making sense or not? I am given a displacement function. The displacement function was x is equal to t cube. I wanted the velocity function. If I want to calculate the velocity function, I'll have to take the differential of the displacement function. The differential of the displacement function is 3t square. Therefore, the function of velocity would be 3t square. Avantika, am I making sense or should I repeat?
I understood what you said at first. The second part, can you repeat again?
Okay. Now, for a motion of a body, I am given a displacement function. So, the teacher gives me that the displacement function is given by x is equal to t cube. Are we clear?
Yeah.
The teacher asks me that can you calculate the velocity function? So I say yes, of course, because I know that velocity is a differential of the displacement function. So I will have to calculate dx by dt. Is it making sense?
Yeah.
Now dx by dt would be 3t square. Is it making sense?
Yeah.
Because I will be following the same procedure that I have followed here. This is a general procedure. Is it making sense, Avantika? Avantika, is it making sense?
Yeah.
Okay. So once I have found the velocity function, the dx by dt is my velocity function. And what is the dx by dt? Dx by dt is 3t square. Therefore, my velocity functions become 3t square. Is it making sense?
Yeah.
Okay. Now my teacher says that please find the acceleration. Now I know that my acceleration is given by this formula. So basically I have to find the differential of 3t square. Avantika, is it making sense?
Yeah.
If I am able to find the differential of 3t square, whatever I get here would be the function of acceleration. Is it making sense?
Yeah.
And how do the functions help us? How do the functions help us? Now let us try. So I have drawn this now. I'm just focusing on this situation where I am given a displacement time curve. I plot the displacement time curve. Using differentiation, I am able to generate the function of velocity 3t square. This is the formula that I have learnt. And I also understand that acceleration would be given by dv by dt. And dv by dt, if I put the value of v is 3t square, if I am able to calculate this, then I will have the acceleration function also. Avantika, are we clear till here?
Yeah.
In few minutes, we will understand how to differentiate this also. That is not an issue. Yeah, that is not an issue. But what is the physical significance? How does it look graphically? Now let us try to understand this. So this is my graph. This is my displacement time graph. Now let me say that at t is equal to 2 seconds. x t is equal to 2 seconds. Where exactly is my particle? My particle would be at this displacement. Avantika, are we clear?
Yeah.
Can you tell me what will be this point? We had discussed this yesterday.
4.
Why 4?
I don't remember why 4, but I remember it doubles. No, y is equal to x square. Yeah.
No, t is equal to 2. So if I put 2 here, what should I get here?
Okay.
I'm sorry.
I don't get your question.
Okay. So if I put, see, this is my t is equal to 2 seconds. Yeah. So this point, what I'm sure is that the abscissa is 2. I need to calculate the ordinate. I will be using this function to calculate the value of ordinate. Can you tell me the value of ordinate? Let me draw a table like this. I think then you will understand. So t is equal to 2, Avantika.
Yeah.
X is equal to t cube.
Cube.
Yeah.
Oh, okay. Now I see what I went wrong.
So the answer would be
8.
Are we clear?
Yeah, I see my mistake.
अरे आप चिंता मत कीजिए, you will get the hold of things faster. Don't worry.
You said yesterday, so I did.
Oh, okay. I understood the mistake.
Yeah.
So if this is t is equal to 5, then let me take this random point t is equal to 5. Then this point would be Avantika
125.
125. Are we clear?
Yeah.
Okay. So using this function, Avantika, what this function, the power of this function is that try to understand that at any given point. At any given point of time, I can calculate the displacement. Where exactly is the point? Do you see the power of this?
Yeah.
Now, I'll just make a jump. Please don't mind. You know the difference between modern physics and quantum physics. So, for example, in chemical bonding, what you are doing is there. The main difference between this is called the classical physics and modern physics is that classical physics says that any time t, you can know the position of a body. But in modern physics, you will understand what they say is that you just have the probability that the electron might be at that place. You don't have a 100% surety that the particle is there. Is it making sense, Avantika?
Yeah.
Even if this is not making sense, in the coming few months, it will start making sense. So now I have using this function, I have the value of my displacement. Are we clear till here?
Yeah.
Okay. Now, another thing now we will be able to do, Avantika, is that we started with this function. Using differentiation, we are able to calculate the velocity function using differentiation. Now, if your teacher asks you that at t is equal to 2 seconds, what would be the velocity? Avantika, can you tell me what will be the velocity?
If you are doing for acceleration, right?
No, we are doing for velocity. The velocity function you have calculated using differentiation as 3t square.
Yeah.
So at t is equal to 2, what would be the velocity?
Should be 12.
12. Correct. How do you know this, Avantika?
See, if you put 3t square, 2 into 3
Shabash.
and raise it to
Shabash.
2.
Very nice. You were given a displacement function.
Yeah.
Using differentiation rules, you calculated velocity.
Yeah.
You know the velocity now is given by 3t square. So if your teacher asks you that what is the velocity at time is equal to 2, you know that you just have to put the value of time as 2 and you will have the velocity. Is it making sense?
Yeah.
Now, if the teacher asks you what will be the velocity at time t is equal to 5, what would be the value of velocity?
45.
No, 5 5 the 25, 25 3 the 75. Is it making sense?
Okay. 1 second.
Is there a confusion?
Yeah.
5 5 the 20, 5 5 the 25, 25 3 the 75.
Yeah.
Medical. Avantika, are we clear or we are?
No, yeah, clear.
Okay. So, using this function and my knowledge of differentiation, I am able to arrive at this. Are we clear?
Yeah.
Graphically, Avantika, what this means is we know that velocity, if it is written as dx by dt, I also know that dx by dt is actually the slope of the curve. Are we clear?
Yeah.
Dx by dt is the slope of the curve. So what it implies is that if I draw a tangent here, Avantika, this value of the slope of the tangent at t is equal to 2 second will give me the velocity. Basically, the slope of the curve at t is equal to 2 second would be 12, and is this 12 is the same as this 12. Is it making sense?
Yeah.
I will repeat. If I am given a displacement curve like this, and using my knowledge, let me take a simple example. If I am given this information that the displacement curve is a function of time using this relationship, so this is displacement, this is time, and my teacher asks me what is the velocity of the particle at this point, all I have to do is basically know how to find the differential of this function dx by dt. So d by dt of sine t. Is it making sense, Avantika?
Yeah.
And whatever value I get would be the slope of the curve at this time. Let me say that this is 10 second. So whatever be the slope of the curve which would be given by this function would be the velocity of the particle at this time. Is it making sense or not? Avantika, is it making sense?
Yeah.
Okay. Maybe one more example will suffice our purpose. So at t is equal to 5 second, I can calculate that the displacement is 125. Are we clear till here?
Yeah.
Let us assume for our purposes that for our purpose, just to manage this question, I'm not much worried about the scale. Let us assume that this point is 125. Is it making sense?
Yeah.
So this point on a xt curve represents time is equal to 5 seconds and displacement is equal to 125 meters. Is it making sense?
Yeah.
Now if I take a tangent at this point, Avantika, if I take a tangent at this point, and I calculate the slope of that tangent, can you tell me what would be the slope of the tangent? What value it will have? Should I repeat the question?
Yeah.
This is my point 5 125. At 5 125, I draw a tangent.
Yeah.
Are we clear till here?
Yeah.
I want to know the slope of the tangent.
125.
125. Why 125? 125 is this value. That is the ordinate, the y-axis value. This is the abscissa. This is 5. This is 125. But I am asking the slope. The slope is given by dx by dt. Dx by dt is velocity. And what is the velocity of the particle at t is equal to 5 second? Is it making sense?
Yeah.
Should I take one more example?
Yeah.
Okay, let us repeat. Let me take example at time t is equal to 10 second. Yeah?
Yeah.
So at time t is equal to 10 second, what would be the displacement of the particle?
1000.
1000. Any doubt?
No.
Are we clear about this?
Yeah.
Okay. Again, I will take I will draw a rough picture because we just want to understand the concept. So let me draw a rough picture and plot this point. Let me say that this is a rough value of my this is x, this is t, this is this point is 10, this point is it making sense, Avantika?
Yeah.
This point is 100, 1000. Is it making sense till here?
Yeah.
And this point is 10, 1000. Are we clear till here?
Yeah.
Okay. Now let me draw a tangent at this point. A tangent at this point. A tangent like this. Yeah. Okay.
Yeah.
Now, I want to find the slope of this tangent. Can you tell me what will be the slope of this tangent?
300.
Why 300?
Because if we do dx upon dt giving us velocity, we use 3t square over there.
Shabash. So 10 square is 100. 100 into 3 is 300.
300.
Because for finding the slope, I have to use the dx by dt function. The dx by dt function is 3t square. Is it making sense or not? Very nice.
Yeah.
अरे भाई तुझे समझ आ रही है? बता दे भाई. Y is equal to, let us take another example. Let me take the displacement as, Avantika, I'll just take 2 minutes to wake Shivang up.
Okay.
Because he has gone into the hibernate mode. Mr. CB, what will be the velocity function? Velocity function बताइए. नहीं आप पहले velocity function तो बताइए. D by dt of t4. This would be given as 4t cube. Now what I am asking is, at t is equal to 2 second, what will be the displacement, Mr. CB? 2, 4, 8, 16. क्या होगा बेटा? Second. Very nice बेटा, very nice. What will be the velocity?
Velocity will be d by 60.
Avantika, what will be the velocity?
1 second, sir. This for this.
Yeah.
32.
Is it making sense, Avantika?
Yeah.
Now, Avantika, if I want to calculate my acceleration function, if I want to calculate my acceleration function, I need to take d by dt of acceleration is dv by dt.
Yeah.
So for calculating acceleration, you have to take the अब डम स्टार्ट चल रहा है क्या? नहीं डम स्टार्ट चल रहा है क्या? Acceleration is dv by dt. You have to take a differential of the velocity function. And what is the velocity function, Mr. CB? अरे ये velocity function है बैल. रैप कुछ भी बोलता है यार. यहाँ पहले लिखेगा ना यहाँ 4t क्यूब, नहीं समझ में आया. अब इस पर हमें रूल चाहिए कि इसको कैसे सॉल्व किया जाए.
तो 4 3 into 4 into t raised to 2.
And that rule, Avantika, is given by this formula. That d by dx of, let us look at this again, d by dx of constant into fx. What does this mean? That if I have to find d by dx of constant into a function, what is the rule that I need to follow? K will come out, that implies this 3 will come out, and I just have to find the differential of x square. Avantika, is it making sense?
Yeah.
And the differential of x square, Mr. CB, is?
2x.
And the answer would be? Avantika, is it making sense?
Not exactly.
Yeah. So, Avantika, our problem was, just let us see our problem. What is the problem? We are not aware how to handle this 4t cube. So we went to our tables where they have told us that if you have to find the differential of a function like this, k into fx, what formula that they are telling us is that what you can do is you can take the constant out and just find the differential of your fx. Are we clear?
Yeah.
So if I am given a function like d by dx of 4t cube, it is a function of time, so I should write time here. All I need to do is just take this constant out and find the differential of t cube. Are we clear, Avantika?
Yeah.
Can you tell me the differential of TQ using the previous formula? This should be. Avantika, have you understood my question?
Partially.
Okay. So the formula that I want to use is this previous formula, that if y is equal to x raised to power n, then dy by dx would be nx n minus 1. nx n minus 1.
Nx n minus 1.
Yeah. So if I have to find the differential of this would be n x n minus 1. Is it making sense, Avantika?
Yeah.
This would be equal to 4 into 3, 12 into t square. This would be equal to 48 t square. Are we clear? No, I'm sorry,
Yeah.
4 into 3, I'm sorry. Let me directly write this as 12 t square. Avantika, are we clear?
Yeah.
So if I have to find the, now let us say that at t is equal to 2 seconds, let us wake Shivang again up. Mr. CB, अब टर्म सराउंड मत करना मेरे साथ. t is equal to 2 सेकंड पे एक्सेलरेशन कितनी होगी?
मैं जल्दी 48.
2 to the 4, 12 to the 48. Avantika, is it making sense?
Yeah.
So let me repeat what I have done. I was given a displacement function. Using the rules of calculus, I was able to find my velocity function. Again, using the rules of differentiation, I was able to find my acceleration function. Is it making sense?
Yeah.
Now, what I am trying to tell you parallelly, basically we are doing two things, and that is why you are a bit slippery. We are trying to do two things. One is we are trying to understand the formulas. Another thing that we are trying to understand is what is happening in terms of the curve. So, for example, if this was a displacement time curve, and let us take a rough example. So, if this was at t is equal to 2 seconds, this slope, Avantika, actually I'll have to wake Shivang up. So I have a displacement time curve, the same displacement time curve. I plotted the graph. This is x is equal to t4. So at t is equal to 2 seconds, Mr. CB, what will be the slope of this curve at t is equal to 2 seconds? Mr. CB is in hibernate mode. Avantika, can you tell me what will be the slope?
16.
But this is the x component.
Okay.
This 16 is actually this point 16.
Okay.
The slope is given by the differential. The differential at t is equal to 2 seconds is 32 seconds. So the slope would be 32. Does it make sense?
Yeah.
अरे क्या समझ आया तुझे सीबी?
कंफ्यूज कर दिया.
कोई नहीं, मैं तेरे से फिर से पूछ लेता हूँ. अरे फिर से पूछ लेता हूँ, तू चिंता क्यों कर रहा है? बहुत क्वेश्चन है. तू अगला क्वेश्चन बता दे भाई. t is equal to 2 seconds again, Mr. CB. Okay, Mr. CB, if I plot a velocity time curve, at t is equal to 2 seconds, what will be the value of velocity, Mr. CB?
What will be the value of velocity?
Yes, sir. पूछ रहा है, बता रहा है. Avantika, have we understood the question and have we understood the answer?
Yeah.
Okay, Mr. CB, if at this point I draw a curve, like this, what will be, Mr. CB, the value of the slope of this curve?
48 meters.
Avantika, have we understood?
Yeah.
Okay, so just to hammer the things a bit more, what I'll do is I'll mention few displacement curves, and you will be required to find the. I will mention simple curves. You will have to find the velocity curve and the velocity function and the acceleration function. Have you understood my question?
Yeah.
You can start.
I have to find a function, right?
Yes, just the function.
Okay.
P x को 2 ले सकते हैं.
अरे सिर्फ फंक्शन निकालना है, क्वेश्चन समझ, वैल्यू नहीं निकालनी. फंक्शन निकालना है, सिर्फ डिफरेंशियल निकालना है. कैसे निकालेगा डिफरेंशियल बेटा? यूजिंग द रूल्स ऑफ कैलकुलस. दिमाग लगाओ बेटा. Avantika, have you understood the question?
Yeah.
रुद्र को समझ आ रहा?
हाँ सर.
Nice.
So I don't have to find the value, right? Just the
Just the function. Just the function. So we know that velocity is dx by dt. Any doubt about this?
No.
So once we have calculated the velocity function, then we can find the differential of the velocity function and find acceleration. Is it making sense? Another thing that we have understood till now is, and I'll keep repeating this because this is a bit tricky, but it will help you understand. It will give you a far better sense of what calculus is all about. So, for example, if I have a displacement time curve, so the velocity is my tangent of a displacement time curve. Are we clear?
Yeah.
And once I have the velocity function with me, velocity as a function of time, I can plot my velocity time curve. Is it making sense?
Yeah.
And using my velocity time curve, let us assume the velocity time curve looks like this. Then at any point I can have the tangent, which is the slope of the velocity time curve, and the slope of the velocity time curve gives me the acceleration. Is it making sense?
Yeah.
So I'll repeat what I'm saying. So for example, if I have a function like I have a function like x is equal to t cube. If this is a displacement time curve, then at each point the slope will give me the velocity. Using differentiation, I can generate a velocity time curve. Is it making sense?
Yeah.
And at each point of the velocity time curve, I can have the acceleration by either plotting the tangent or just putting the value of t here, and I will have the value of actually I'll have to take the differential of dv by dt. So to calculate the tangent at any point, I'll have to take a tangent, the differential of this velocity curve, which will be equal to 60, and at any time t, I can have the slope of a velocity time curve, which will give me the acceleration. Is it making sense?
Yeah.
So this is what we want to understand. And another thing, again and again, why I keep repeating about the value of curves is that once you know that how t cube looks like, you know how t square looks like, how t looks like, you get a fair amount of idea in terms of graph what is happening.
Yeah.
So for example, if you know about curves, then this t cube curve will look something like this. The t square curve would look something like this, and you can see that the acceleration time curve is a straight line, so it will look something like this. Is it making sense?
Yeah.
We should have a very firm grip over the graphs, because your competition based questions are usually graph based questions, because that is where most of the students lack. So if your grip on the graph is good, then you'll tend to do good in competitions. Are we okay till here?
Yeah.
Okay. So let's quickly just go through the functions. So what will be the velocity function? One thing.
5t raised to 4.
5t raised to power 4. Shabash. What will be velocity function for this?
6t raised to 5.
Shabash. What would be the velocity function for this?
7t raised to 6.
Shabash. What will be the velocity function for this?
6t raised to 2.
What will be the velocity function for this?
12t raised to 3.
Are we clear?
Yeah.
So the formulas that we have used here is that dy by dx, if y is equal to x raised to power n, then dy by dx is given by n x n minus 1. And another function that we used, another formula that we used was that if y is equal to k x raised to power n, where k is a constant, then all that I need to find the dy by dx is just keep the k outside, just keep the k waiting, and find the differential of nxn. Is it making sense?
Yeah.
Yeah, these are the two basic formulas that we have used, and basically in this lecture we have got a gist of how differentiation would be helping us in physics. Have you understood what I've said?
Yeah.
So let me ask Mr. Rudra. Mr. Rudra, what will be the acceleration?
20t cube.
20t cube. Shabash. Mr. Rudra, what will be the acceleration here?
30 raised to 4.
30t raised to power 4. Shabash. What will be the acceleration here?
42t raised to 5.
Shabash. Very nice. What will be the acceleration here?
12t.
12t. Shabash. What will be the acceleration here?
36t square.
36t square. Shabash. And let us trouble Mr. CB now. Mr. CB, at t is equal to 2 second for this function, what will be the value of x, Mr. CB?
16.
कितना?
16.
6 बोल रहा है, t बोल रहा है, क्या बोल रहा है?
16.
तो बेटा स्टाइल कम मारा कर और आंसर ठीक दिया कर. बोल वेलोसिटी. जी जी जी
24
24 मीटर
meter per second.
पर.
Second.
शाबाश शाबाश बेटा शाबाश. एक्सेलरेशन
24 meter per second.
Avantika, are we clear?
Yeah.
So what we have understood in this lecture is that if we are given functions, if we are given formulas of finding differential of functions, then using the formulas of functions, the differential of the formulas of function. So let us assume that we are doing motion questions. Then if I am given a displacement function, I can generate a velocity function. If I am given a velocity function, I can generate an acceleration function. Are we clear till here?
Yeah.
See, motion is the easiest to understand.
Hmm.
So for example, I can use the similar formulas for in electricity chapter also. So for example, in the last lecture I was telling you that in simple harmonic motion you will be given a function like this: x is equal to a sine omega t. Let us forget what all the meaning of all the words. I am telling you that this is a constant and this is a constant. Now, what I want you to realize is that if I am given a displacement function, this is for a simple harmonic motion. Body which is tied to a spring, which is remember we were discussing it yesterday. A block which is tied to this spring, and then we set this spring in motion, and this body does a motion in to and fro. Do you remember?
Yeah.
So if I am given a displacement function, can I generate a velocity function? Can I generate an acceleration function? If I know the rules of differentiation, is it making sense?
Yeah.
So that is what the purpose of this lecture was. Now, as a homework, what you need to do is, I will be sending this PDF. I think Mr. Rudra already had this PDF. So the formulas, I will just show you the formulas, and they are pretty easy formulas. You won't face much difficulty. So for example, this is the first formula. Yeah.
Okay.
Just do any six questions from this. Have you understood what I've said?
Yeah.
Any six. Yeah. This is the second formula. S is equal to T. Simple formula. And do maybe, let us say, again 6 questions. They are very simple questions. Once you do 2-3 questions, you will understand what I'm saying. This is the third formula. Again do 6 questions. Have you understood what I've said?
Yeah.
This is the formula that we have done today. Again do 6 questions. Any 6 questions you want.
Yeah.
This is the fifth formula. Again do 5-6 questions. This is the sixth formula. S is equal to Tn. Again do 5-6 questions.
Yeah.
This is the formula. These are the basically all these are the basic. Basically, we discussed 2 formulas of differentiation today. This PDF is just a modified form of the 2 formulas that we have discussed. They have broken those formulas further, so you won't face any difficulty. Don't worry. Look at this formula. Try to do 5-6 questions. Look at this formula. Again, try to do 5-6 questions. You have 3-4 days with you. You can ignore this formula. 10th you can ignore. Maybe 11th also you can ignore. This would be a bit tricky. If you want to do, you can do, but this is a bit tricky. You can ignore 12th also. These are miscellaneous formulas. We don't have to do this. What I wanted to show you was that you will get the answers to all the problems at the back of the PDF. Have you understood what I've said?
Yeah.
This is one of the best worksheets that I've been able to find on Google. These are the people who make these worksheets. So good website. So I'll be sending this PDF. We have to basically learn the formulas till 9 formulas we'll have to learn. We'll be able to do this by Monday?
Yeah.
Okay. So let's meet on Monday.
Yeah.
Mr. Rudra, हो जाएगा?
हाँ।
ठीक, Monday मिलिए.